Okay, let's do one more example with the butterflies, and this time we're going to talk about instantaneous rate of change. So what if I were to say, again, our equation was b of n, so the number of butterflies after n years was always equal to 4n squared minus 2n plus 6, and we already, let's say the question asked, this is the number of butterflies in G-land, by the way. Let's say the question asks, what is the rate of change of the number of butterflies in G-land in the year 2000. I guess we should say what was, because that was 12 years ago. All right. Well, this time I'm not giving you 2 different years. I'm just giving you 1 year. So I'm obviously not looking for the average rate of change. I'm looking for the instantaneous rate of change. Exactly that year, what was the rate of change? I'm not asking how many butterflies. The number of butterflies would be easy. I would just plug in n equals 10. So it would be 4, so 10 times 10 is 100. So 400 minus 20 plus 6, it would be 386 butterflies. But that's not what we want to know. We want to know how much is it increasing in that year? What does it go from and to, and what does it increase in that year? This is an instantaneous rate of change. And it's exactly at that one point if it were a smooth thing. So the year 2000, we would actually say instantaneous rate of change is equal to the limit as h approaches 0 of, let's say, b of 10 plus h minus b of 10 all over h. So we're finding the spot right at 10, b of 10, which is 386. So 10 comma 386. And we're going to take another spot that's just a little bit beyond 10. So the year 2000.0001. So like a fraction of a second after the year 2000 started. And we're going to see how many were there, and we're going to find the instantaneous rate of change at that time. Because we're going to take the limit as h approaches 0, and that will give us the actual instantaneous rate of change. Okay, so this is equal to the limit as h approaches 0 of, well, b of 10 plus h. b of n is 4n squared minus 2n plus 6. b of j is 4j squared minus 2j plus 6. b of smiley face is 4 smiley face squared minus 2 smiley face plus 6. And b of 10 plus h will be 4 times 10 plus h squared minus 2 times 10 plus h plus 6. So we're saying 4 10 plus h squared minus 2 times 10 plus h plus 6. This is b of 10 plus h minus b of 10. Well, that's just going to be 4 times 10 squared minus 2 times 10 plus 6. I have to put these brackets because this says b of 10 plus h minus b of 10. It doesn't say minus the first part of b of 10 or part, maybe the last part or the middle. Don't worry about the rest. It's minus b of 10, the whole b of 10. So this is b of 10. We have to subtract this whole thing, not just the first part of it. So I make sure I put brackets to represent we're going to subtract the whole thing. Equals the limit as h approaches 0. So of 4 times 10 plus h squared is going to be 100 plus 20h plus h squared minus 20, 2 times 10, minus 2 times h, so 2h, minus, this is going to be 400 10 squared is 100 times 4, so minus 400. We have a subtraction here, so it's minus a minus, so we have plus 20 and minus 6 all over h. Now, let's erase the top part here. This is equal to the limit, as h approaches 0, of 400 plus 80h plus h squared minus 20 minus 2h minus 400 plus 20 minus 6 all over h. In this last part, we know that everything without an h, we can expect it to disappear on us. This negative 6, there's also going to be a positive 6 somewhere. Oh, I missed a positive 6 here. 2h plus 6 should be right here. Plus 6 minus. So maybe you guys noticed that a long time ago, but here I forgot a plus 6. And that was actually, it's good that I knew that this minus 6 is going to be canceled, because if I had done this, I was going to end up with something where the h would not cancel. So that actually helped me to know that. So it should be, after the minus 2h, there should be a plus 6 right there. So we have a minus 6 and a plus 6 that actually do cancel. We have a plus 20 and a minus 20 that cancel. We have a minus 400 and a plus 400 that cancel. And all the rest have h's and h squareds in them. And the good thing about that is that we can actually take out an h from the top. So 88, we're going to put h times 80. So this will be 80h. Plus h squared, so plus h times h. Minus 2 times h. And that's all we have. So this is actually 80h plus h squared minus 2h all over h. And of course now, just like we're used to, those h's cancel out. And the great thing about that is now we don't have to worry about the limit as h approaches 0, because we don't have an issue with h being 0 anymore. There's nothing on the bottom. We could actually let h be 0 at this point, and we could say this is equal to 80 plus 0, because h is 0, minus 2, which equals 78. So actually in the year 2000, which is 10 years after 1990, this prime means I actually took the instantaneous rate of change at that point. So instead of saying b of 10, which would be the height at that point, I'm taking b prime of 10 is what you call it, and saying the instantaneous. So this is a little symbol, shortcut symbol for you guys if you want to use it. This only works for instantaneous rate of change. It won't work for the average rate of change. So the instantaneous rate of change at 10 is 78. What does that mean? We say, therefore, in the year 2000, the number of butterflies was increasing by 78 butterflies per year. At exactly that point, it was growing at 78 butterflies per year. So if you actually kept that rate of change from then on, you would add 78 butterflies every year. But we know it was a quadratic, so it's actually going to increase even more than that. But if you had kept that rate of change, it would be 78 butterflies per year. So your homework, you guys already know, is, we're talking 1.3, I believe. So it's page 29, numbers 1, 2, 4 through 6, 9, 10, 12, and 20. Enjoy.